looking at how to get this to scale to something. And I also like fiddled around with these kind of handmade reverse indices and some kind of production rules style optimizations and doing it in a smart order and something like that. But yeah, I think differential right from the get-go, there's still a lot of room for optimizations in a like a web use case with many concurrent users. But from the point of view of updating these things like a query and with low latency and high throughputs, it's very general purpose, and it supports like all of the cool data log stuff, so recursion, mutual recursion rules, all this kinds of stuff.
Is there anything it can't?
Let me think. What it can't do, for example, is user-defined functions. So you don't get them because it's not a closure runtime or anything. So you can't just transact any kind of like custom or use any kind of custom functions within a query.
So how would you do? We have a demo on our homepage of using closure.string/includes.
Yeah, exactly. These kinds of things. This all has to be either handled client side or there has to be a built-in function for this. In the near to medium future, for the longer term, we're quite interested in WebAssembly because we have the whole system building to WebAssembly because it's written in Rust. Like the backend is written in Rust, and the Rust to WebAssembly story is pretty good. And the closure script to JavaScript to WebAssembly story is also getting there. And so you have a common runtime where you could. Oh, you're still there? Oh, yeah.
I'm here.
But right now there has to be a handoff. So we're mostly using, or we're thinking about differential as kind of like a data router. You use it to do like the heavy lifting and filtering and joins and whatever, and then things like if you need to do some formatting or applying some transformations like you would on an SQL result set, that's probably right now better handled in the client.
So other than the limitation of no peer functions, the basics like the schema model would be identical.
Yeah. There is so far we haven't come across anything that's like fundamentally different. So it's still a work in progress, but the plan is to if you run this on top of Datomic and you point it if you run it on top of Datomic, you don't even need to do anything because we just read the DB idents and the schema configuration from the transaction log and set everything up. There might be a thing about data types, like if you use one of the like the instant type or something like that. Haven't tried this in practice how it maps between Java and Rust world, but in principle it should. Yeah, I think in principle we support the same data types, and keywords might be another thing if you use keywords as value types. But then it starts accepting datums, and should work same way.
How about speculation, as in datomic.api/with?
Yeah, that's cool. So for the historical side of things, it would be supported. So it's fully immutable. You can just say like, give me the state of the stream at like some transaction in the past. But it's not too interesting because then it won't change ever after that. But what we do is like give you this bitemporal modeling or like multi-temporal modeling, where you can say, okay, give me the stream as of a time in system time and show me how like event time evolves, and the other way around, and with more than 2 dimensions. And what you can also do is these speculative kind of queries where you say like, okay, I have this stream of results and at some transaction in the past, add some speculative edges to a graph or facts into the database, and then you will get the diffs from the main line to the speculative line. So that is also supported.
So if I understand, that means as your staging area that goes through dwidth changes incrementally, the queries can still react to changes in the dwidth.
Yes. So it would be, you don't have to like if you go back in time and speculate with some transaction, you don't have to recompute everything fully up to where you are now, but instead you get like the changes from what you computed before. So it's kind of hard to describe, but if you do some kind of graph search or something, some algorithm and some query, execute some query, and then one of the results of the query, you basically invalidate them with a speculative transaction, then you won't get the whole result set minus this invalidated tuple, for example, but you will just get like, hey, take away this tuple. So then it matches and you can keep whatever you had before. And so it should be like, as I said, still a work in progress, but it should be pretty efficient to do things like, okay, I have a version of the UI that's rendered in React or something, and then I render it twice with a speculative stream and one with the real stream, and should all be as performant as it could be reasonably.
Okay, so when you talk about it sitting on Datomic, so you've got Datomic as a source of truth, so you're not even worried about the transacting side, you're just
not at all. Side. Yeah.
And the queries run in a Rust server that can run distributed.
Yes, yes.
And how about a browser?
Yeah, same thing about the WebAssembly story. So it started as a project that was intended to run in the browser. No, not differential itself, but just the data log side on top of it. And it works. It runs in the browser, but it's definitely not. I mean, you're running like a server grade thing with lots of systems level features in a single threaded browser environment. So that doesn't make sense in principle, but you could. But we're mostly thinking about this. The intersection would be the client in the browser is running something like DataScript.
Yes.
And you register like whatever the needs of all of your clients are locally. You register them as data log with the server, and then you feed the result stream that you're getting. You feed that into DataScript or into multiple DataScript instances, and then you just work with them locally.
But if you registered the queries with the server, then the query can't change, and what's the point of having DataScript at all?
Just if you, yeah, I mean that's true. If you do some kind of synchronization between server state and local only state for some web application or something, and you want to have like UI things handled in DataScript as well, then you would use the server part to feed it in, and then deal with that.
Okay, but for like for getting local state to the UI for any type of state that's source of truth in the database, DataScript doesn't have add any value.
Not really, no.
Right. Okay.
No, you get a WebSocket connection with tuples arriving, and you do whatever with them. So, for example, for visualization stuff, we feed them directly into D3 or Vega, and for other types of things, yeah, we could see what makes sense.
So for the pure functions set you can't do? What if you know the set of functions in advance?
Then it's no problem. Then you implement them in yeah, basically if you know what you want to do and you just implement them as built-in functions in Rust. So it's quite pluggable. You can change like the underlying data model in a bit. Data model meaning like how we arrange the tuples. You can do it like column oriented or the same way that Datomic does it. So there's kind of performance trade-offs there. You can do that, and you can also change the front-end language if you want to use it. And what you can definitely do is add more specialized operators, add specialized built-in functions, etc., and implement them all in Rust. That would be the easiest. And if you need something more complex where you want to integrate with completely different runtimes, what you can do is run a server in whatever language you need. For example, Python, some model or something. Which uses the same kind of API. So I declare my interests in data log, I get data, I run some computation in a completely different environment, and then I publish whatever I'm computing. I publish it as a new attribute to this differential cluster, and then everyone else can just continue using this attribute as if it would have been stored in the database, but it never actually touches Datomic.
But you have to model it as schema.
Yeah, you need some way of like avoiding naming collisions and giving good names to these things, but you don't actually have to model it in your schema.
So it's not in Datomic schema, but there would be a separate layer of schema that has these derived attributes.
In a way, I mean, we're not completely clear on the best way to do this right now. We are imagining something like it would be part of the Datomic schema in such a way that there is just this attribute registered in a Datomic with some metadata, maybe telling you, hey, this is not an actual attribute, but this is like a derived thing. Mm-hmm. And then just use this to keep the names synchronized and avoid name clashes. And then everyone else has to talk to differential to use those. But this is only like, this is intended for things which are just derived, so which do not never need to be persisted or anything. You can also feed it back into Datomic or feed it back into like Kafka or whatever.
So this is funded research through the university system?
No, it's not really funded. It's like the project itself, Differential Dataflows, so the underlying technology. It goes back to, I think, Microsoft Research, and the person who is doing it now, who's my advisor at ETH, he is basically, it's his system now. It's a complete rewrite of the original system, MIT license, whatever, and he has like some PhDs here working on it. But what we're doing is mostly for me, it's just like a master's thesis, and the rest is from my with basically outside of the university context. So we're working on it to commercialize it, to bring it to companies for like replacing Spark and stuff like that.
Okay, so tell me more about your commercialization plans. I mean, this is speculation at this point, right?
What do you mean speculation at this point?
Is this a business, or is this?
No, what I do on the side is software consulting, like plain old software consulting. And this is intended to be a business, but we're not quite sure yet in what capacity. So the core of the system, what is now on GitHub and the declarative stuff, this is all going to be, I think, MIT license or whatever it is right now, and stay like that. And we're right now mostly looking at doing consulting gigs with this technology. So we're talking to companies and replacing these data pipelines that they have and getting them customized, query engines, domain-specific stuff, things like that. We would be interested in looking at like maybe kind of collaboration with the Datomic people as a React kind of Meteor or Rethink DB type of arrangement for Datomic, but there's no real plans there yet. And what will be what is not open source yet and doesn't exist fully yet, and we're thinking about keeping it proprietary, is related to the optimizations required to use this with like many thousand concurrent users, which would then share parts of the same data flows and rearrange things, basically like you would have in a relational database, a query planner or something, have this for the streaming use case and for the data flow use case. But so far, this is why I'm talking to people now, just figuring out kind of what people are interested in. I get the Rethink DB thing quite a lot, and we're not sure yet what this will be from the commercial side. But whatever is available now will just be available.
So I'm like this would be Hyperfiddle needs something like this in the future, but it also needs the Datomic Ions product.
Yeah.
Because when you run Hyperfiddle in a serious configuration, right, that's the secret sauce to making it work at scale.
Yeah.
So how it strikes me that it still could work with what you've built in Rust. It wouldn't run in Ions, but it would run in AWS in Elastic configuration.
Yeah.
And it can drop and replace any Datomic query that does not use pure functions.
Yes.
Without changing the result.
Sorry?
Without coming to the same result.
Yes, yes. Ions is actually interesting, I think, because Ions is somewhat of it shows that like their philosophy to keep the thing working at scale is have everything move the code to in the same process as where you have the peer caches, which is in a way it's a super cool approach, and but somehow opposed to what we're doing. We're saying like, don't mind the runtimes, don't mind what you're looking at, as long as you can speak data log, we can efficiently get you whatever you need. Like imagine the Datomic peers coordinating with each other. Basically, they have the same problem, right? They need to know what to keep locally based on the queries they're seeing. And so this is kind of a way of abstracting this without having to be part of the caching network. So in a way, we don't have to run in IANS, but we can definitely, as you said, run in AWS and interact with code that is running in IANS.
Is it, you just said something interesting. Is it true that in a future world where you worked closely with Rich Hickey, you could provide an implementation of the IANS caching layer, which right now is probably very simple cache. Maybe it's not simple anymore, I don't know, but like the least reason to use cache or something as you might expect.
Yeah, I imagine.
And it pulls the datums it needs and whatever. You could re-implement that better.
I don't want to say better when Rich Hickey is involved, but like in principle, it would be, yes. You could just, the peers would keep track of all the cache, the queries, and either do something clever and try to find like a superset of them, or just register them all with each other, and then update data flows. Yeah, so that would be a plan there, or not a plan, like that would be a thing there, but yeah.
Why? Okay. So you can't do peer functions, but you can do them if they're implemented in Rust. Now, can you do arbitrary peer function if it was implemented in Rust?
Yes. So the differential layer is intended to, everything you can do with your computer, you should be able to implement as this kind of data flow. The thing is, so the guarantees that we give about incremental updating. So the guarantee is like all of the differential operators will only ever do work on the size of whatever you're changing. And this will be broken if you have operators that use like arbitrary Rust code, which is not incremental. So if you do, for example, if you do an aggregate, and whatever your aggregate function is like classic Rust function with lots of loops over all of the data set, or doing requests to some other system, then of course the guarantee will be broken. What you can do then is use other techniques, like simpler techniques for single-threaded incremental execution, like dynamic programming basically, and implement your operators like that. So you have to be clever and you have to know the system basically to keep the guarantees. But for simple things like custom aggregation functions, predicates, whatever, that shouldn't be a problem.
How about like subqueries?
Subqueries.
Calling Datomic API Q as a pure function inside of Datalog.
What do you want to call? Is it like a specific thing?
I'm going to make this concrete with an example. I'm going to share the screen if that's okay.
Does it work? Oh yeah.
Okay, so this is a little hyperfiddle prototype. And this query here, this is extremely hacked and not idiomatic, but the point is that it's possible. It's something that we do sometimes.
Oh, so you call out you just execute another query within the query.
Yeah, and this works.
That's cool that it works.
Well, it makes sense because this is
it's
pure
just
function.
No, interesting. Cool. So, for subqueries, like the way we intend them to be used, so this would definitely not be possible out of the box because, as far as I know, there is not a Rust client for Datomic.
Right.
So implementing this would be pretty hard. But this looks like, I'm not sure if it's doing anything special, but if what this looks like is if you register the query within it as a separate rule, why does that not work?
I think that would work. Yes. I mean,
Okay.
I don't really understand fully rules. But
Okay, so to my mind, everything like the query on top is just a weird way of writing a rule, and everything else is just ruled. So the unit of composability for queries would be rules.
okay.
So in this case, if you register a query on the server, you can give it multiple queries and tell the server not to publish all of them globally and just reuse them locally. This is also how you get like mutually recursive definitions. And this looks like it would be just a nested rule there, where you say like the bitb bankroll update stuff would be a new rule, and then you use that within the top level query.
Okay, yeah, that seems right.
Oh, I was going to ask, yeah, because I looked at the live demo on the website, and I think it didn't have support for rules yet, right?
We haven't plumbed them through yet. We'll do it eventually.
That's probably quite risky on your end if like people shoot themselves in the face with the recursive rules, and same for us. But I mean, like that's quite a bit of power there.
Yeah, we basically would need to do what something like App Engine or AWS does, or Ion, and run things in Lambdas, such that like it's bounded and metered, and they pay for their own capacity.
Oh, I see. Yes.
It can be terminated if it doesn't respond in the time frame.
Yeah, definitely. Yeah.
So we're on the path to having that.
Cool. Yeah, but I think this would work. Calling out to Datomic in general from Rust would probably be hard.
Right. You would need to mirror the API exactly, essentially, in Rust.
I mean, you could implement. Yeah, you would have to implement the Q function basically in Rust, and yeah.
What if we implement your abstractions in Clojure?
So I think implementing the underlying system, like all of differential in Clojure, in principle, of course, then you'd have the same thing, but it's probably going to be hard. Like I thought about that myself. I wanted to at the start, I wanted to just re-implement the whole thing in Clojure, but yeah, I mean it's quite an involved system in the details of doing things like recursion and stuff, and resolving that incrementally without violating anything. And there's I think quite a bit of thought that went into the Rust implementation. So it would be non-trivial, but sure, if you do it, then you avoid the problem.
How many man years of thought do you think is in that Rust implementation?
That is because it builds on like a long history of. It's basically one of the only systems doing this kind of differential computation model. Like there's one proprietary database which it's called Logic Blocks, which apparently is doing some of the same things, but maybe not as well. But so it's a pretty unique thing, and I would say a lot of man years. I can't really do the comparison because it's man years by someone who has thought about this for a long time before and is doing it now. And I'm just like beginning to grasp like all of the things that are part of the system.
Okay. So
re-implementation, yeah.
Okay. So it's not something that someone can learn. It's something that you have to find the team who did it.
No, you can definitely learn. I mean, there's documentation on how it works. There's papers on this, and you can definitely learn. I mean, I've been doing that for the last year, but it's, I think, a non-trivial distraction to try and write this in Clojure. There is someone, I think he works at a company called Mode Analytics. His name is Josh Ferguson, I think. Apparently, he is looking at implementing some of the things in TypeScript, but just as a single-threaded like front-end kind of thing, not with the distribution aspect. And I mean, yeah, I can't judge how far along he is or how well that's working. I would say the easier thing would be looking into getting WebAssembly to be the main runtime there. Because I think, I mean, that would be pretty experimental right now, but there is experiments in running WebAssembly binaries directly on Linux, and there is definitely proof of concept that this backend system runs on WebAssembly and that the closure script runs on WebAssembly. So that I think would be the much easier and nicer way, and would open it up to everything that can compile to WebAssembly to be used as peer functions in the sense. So will also take like a while, but seems more realistic at this point.
Tell me more about your role in this. So you're a grad student, and you also are a consultant in your spare time.
Yes.
What are you doing next?
So I'm a grad student now. This has been like a research project so far, and this will be my thesis project for the next 6 months. So my master's thesis. And apart from that, during the thesis, we'll be mostly looking at the concurrent users use case. So like optimizing this thing automatically instead of hand building data flows.
Okay.
And then we'll see. I mean, we're talking to quite a few people now, and I'd love to have this be like a thing, be a business, and focus on this space like data infrastructure, query languages, stream processing from the consultancy. We'll decide. We'll give this like a couple of months to get feedback and see where it goes, and then decide next year whether we're actually going to do something with this full time.
What's the biggest risk that you see?
For you as a user?
For like the technology as a whole?
The usual things like ecosystem and documentation and mindshare, because like if you compare this to, it completely like as a stream processing system without all of the data log fanciness on top, it completely like blows out Beam and Spark and all of these things. But you would not be able to like give this to someone and say like, hey, build your system with this, because it's not production ready in the sense that it has been used in a production environment, and it lacks documentation and all of this. This is probably by far the biggest risk. So you always need someone who kind of has some experience with it to like build it for you or like maintain it for you.
But you're quite bullish that the technology does what you think it does, and that it has great value in the applications that you think it does.
Yeah, definitely. So, I mean, we're using it internally now for like, we're not at a scale where it's totally interesting, but like we're building stuff with it. So we're hoping to discover issues like that. It's definitely been like benchmarked a lot of times in the research environment. So like just doing some kinds of problems and comparing against other systems. It definitely does what it's supposed to do, and I'm quite optimistic that it at least can provide like a valuable angle to this whole incremental query maintenance thing. Risk-wise. I mean, can't really say anything more specific than it should be put into like a real world scenario, and then we can definitely say more what's happening there. We're hoping to like do a bigger proof of concept with an actual real world use case end of the month, and see whether it like breaks down horribly, because it's a rather simple use case. So it's not in data. There's no data log involved. It's just like run this thing in production as a stream processing system. So if that goes fine and goes the way we're planning, then we'll definitely be more confident.
So when you mean run it as a stream processing system, I've been picturing the stream basically being the Datomic transaction log. It can be anything else that's shaped like that.
So for the underlying thing, it can be anything else, and you just feed it into this. There's like a data model. It's based around so-called collections, which in a way which are also like immutable collections in Clojure, but instead of being oriented around snapshots and trees and stuff like that, they're just accumulations of diffs of like updates so this is a rather flexible model, because the data part of the collection can be almost anything. We use it a lot for graphs and modeling edges and stuff like that, which can be done much more efficiently than Datomic, which is much more general, of course. But yeah, you can feed it almost anything, and we're definitely also not only looking at connecting to Datomic, so we're connecting to Kafka and reading from files and connecting to Postgres and stuff like that.
Okay, so it doesn't have the limitation of limited write throughput that Datomic theoretically has.
No, it has. No, it hasn't. Yeah, it can. Having the limited write throughput is, I think, nice as a source of truth, because you will get perfectly ordered, consistent things. But you can definitely use it with something like Kafka, and then use maybe some approximate timestamp to stay as consistent as possible. But yeah.
You could use it as an input to Datomic too. You could have some real-time stream that filters down to a database value and then inputs to. I don't know why you'd want to do that though, actually, because you already have the ability to have reactive queries across it.
Yeah, I think it would be still. I think there is still a lot of value for having either Datomic or DataScript as databases to talk to, if you can afford it, like from a scalability point of view. If you don't need the Kafka style things, because of the testing is so nice. If you do things like dealing with the database values locally or something, I don't think it would be as nice with the stream paradigm, because yeah, I think that would be weird.
Okay.
So ideally, it would be, you could use Datomic and then just tack this on if you run it in production and need the real-time sync and need the reactiveness of it. So whatever the underlying system offers in terms of write throughput, unless it's much higher than what we can do, but databases usually, like, they have to do much more stuff, so they probably will not be as efficient. So whatever kind of throughput and consistency guarantees the underlying system offers, if there's some kind of consistent timestamp, then we can use it, and all of the results will be maintain the same transaction guarantees. Actually, this might be like, if you do not require this kind of consistency guarantees, like there is ways of making the system much easier, much more scalable, if it's just like best effort, whatever happens through, like just do some streaming computations. So one of the bigger selling points of this would be that it actually does things correctly. So you get if you run the same way you would if you run the query directly to Datomic, you expect some certain kinds of transactional guarantees, and we would maintain those. And if you don't need those maintained, then there's probably ways to tune the system, or to like use an entirely different approach to get maybe like an 80% solution and no guarantees.
Well, this is amazing. Is there anything else that I haven't asked that we should talk about?
From my side, that's okay. I mean, it's for Hyperfide, just from the demo that you see on the screen, it's pretty clear, or it seems pretty clear what the use case could be, and that you just do not hammer Datomic all the time, but have it update incrementally. I think. No, mostly from my point of view, it's basically, I want to know whether the real-timeness of it, or like the rethink DB Meteor-ish aspects, are actually value adds, or whether that is mostly for nice websites. So no, I don't think this was the gist of it. I will be talking about this at the conch, and I will have more. I think I have a blog post about this, like a very high level thing, and we will be publishing more in-depth blog posts, demo use cases, and stuff like that to play around with it. And right now, the front end and the back end are like completely unstable, in that we work on one and break the other, and then so it's not something that's super nice and usable right now. We'll try and get there over the rest of the year.
Okay, well, I'll digest this. I'm looking forward to your talk.
Yeah,
we should talk again in Raleigh.
Yeah, you will be there, right?
Yeah, of course. Yeah.
Cool. Yeah, no, I'm super. I think this would be quite a cool combination, because I think you also talked to the Datomic people, right?
Yeah.
You said you gave them like a demo or something on
Mm-hmm.
the blog, and I think we have at least one other, apart from ourselves, there is one other company here in Zurich which are also looking at using Datomic in this kind of reactive way. And so I think talking with you and talking with the Datomic team would be pretty interesting, in seeing like how we can get this story for like most of the Datomic community, not just like special use cases. Because if you I mean, I'm not sure what the plan is with Hyperfide, but I can imagine things like visualization and these kinds of business app use cases. If you go towards them, then I can imagine this being quite natural fit to create dashboards, create all these kinds of systems.
Right. The interesting thing about Hyperfide is it tries to be like a general purpose, one size fits all backend for like the 90% of software.
Yeah.
Which is kind of what Meteor tried to do, except it turns out that the corners that Meteor cuts like matter a lot, like data corruption, transactions, different queries. So Hyperfide goes really far, but I think the real-time aspect matters to a lot of people making applications. Like you look at what people spend money on and the features they develop in their apps, and like from the beginning, they were all spending a lot of engineering resources on trying to have like the real-time updates, right?
Yeah.
Like, and especially simple things like, well, I submitted a transaction and I need to make sure that like, I never get stale reads or that type of thing. And people spend a lot of energy in fixing little things like this.
Yeah. Yeah.
So a system like this, if it was general purpose or close enough to general purpose that no one noticed, that I think is really important.
Yeah, I think so too. I think also, which is why I focus on Datomic so much with the work, is I think it's uniquely suited to be that kind of thing, where you have like a insanely good database for development purposes and for whatever, and for actually making sense of information and not throwing it away all the time. And then something that closes the gap, like for regular people, like what you want to do with it. And there was something just a while ago on Hacker News, like some basically drag and drop these kinds of enterprisey applications together on something.
Retool, yes.
Yeah, right. I think that's what it was called. But I think like Datomic has a lot more to offer for these kinds of things. If you look at auditing and historization, and I think like people are always blown away if you show them, if you build software with Datomic and you show them something like, here you can flip through your changes, you can flip through the history of this graph or something, and there should be something there. So yeah, that's super cool. I'm looking forward to hearing more and seeing more there, and see you in a month.
Very cool. Hey, I recorded this. I didn't get quite the beginning. I'm going to transcribe this and put it on a blog post, if you don't mind.
I don't think I mind.
Okay, I'll send it to you first, and we'll see what you think then.
That'll be cool. Yeah, but other than that, nice. Cool. Then see you then, and all the best.
Take care, Nico.
Bye-bye.